functionality is working as per expected. Introduction of this in embedded system testing, it is a crucial for ensuring that embedded systems are reliable, efficient, and safe for use in the real world application. What are the real world application? Like the car, medical devices, or home appliance, industrial machines, and many more. So it will be specifically designed for the applications which we use. Testing is a complex and multi-factor process because these embedded systems often consist of the processor, CPU, and timer that should be operated in the as per the scheduling time. And the hardware which should be interacted with the other components, it's able to operate specifically the function which configure in the software. Why testing is necessary? Because to check the functionality correctly and performance should be work as expected, and safety and reliability is the main concerns should be considered for doing of the testing. Testing is crucial to avoid the system malfunctions and incorrect interaction between the hardware and software, and failures relevant to the time sensitive operating, and security relevant features that able to configure towards the software or the hardware. It should be monitored and it should be secure towards the design and towards the development activity. The main key aspects of embedded software testing involves the hardware-software interaction. It can be validated in hardware in loop and ensure that the communication is established between the devices are able to transmit and receive the data. And we need to observe the real-time behavior, how the system is performed on scheduling of the time based. And next will be the power consumption. Every device, it has some limitation to utilize the power, and reliability and stability. So if the long run of this hardware or the software, it should be stable and reliable. And security is specifically talks about the software encryption or authentication relevant to the examples of the face recognition or fingerprints. Some of the identification of the factors how able to configure in the software towards the hardware devices. And the communication interfaces, it will be the wired or wireless, how significantly we are able to communicate with the hardwares that should be configured via the IP address, or if it is wired Ethernet or wireless. And user interface, specifically the response we are able to validate on the display. And compliance and standard, for every process of development towards the hardware, we should have some safety features that should be considered. It have a part of the compliance and standards. And code quality coverage, when we are making the software for specific applications devices, we should ensure the quality, the coverage of the code, it should be error free. Failure mode analysis, if any failures able to trigger during the device operable, that failure should be identified and fixed, and it cannot create a major damage during the execution of the product. So how that can be identified? And timing and synchronization, it's the important activity that should be performed within the software, where the timing and synchronization is considered as the real-time response for the system. And what are the testing methodologies for embedded system? Here it includes the manual testing, where we are able to perform manually and the functional and behavior of the software and hardware can be tested. It will be the physical device where we are able to operate the sensors and the actuators and to check the functionality is working as per expected. Automated testing, so with specific to the tools, we are able to perform the code level automation and the selective test cases with respect to the regression or unit testing. With the help of tools, we are able to automate those test cases and we are able to do the testing. And the script, we can use the test script or the simulation tools for doing the automation. Similarly, it will be a part of a in-circuit testing where the hardware will be tested each and every pin, the corner, to ensure that the hardware is working efficiently. It cannot be create any damage to the product. And it involves the completely the physical hardware when we are integrating those devices. And it is a specialized equipment used to test the system behavior with the actual operating environment. And the other part is the hardware in loop testing. It includes the software will be tested and how the system will be controlled with respect to the software that will be validated with the physical connectivity in the real-time tool. And the hardware components are connected to the simulated environment and allowing the system to be tested under real world condition where we'll give the inputs like sensors, digital inputs or analog inputs will be given and we'll validate the complete features in the HIL testing. And what are the testing methods that will be involved for doing the test embedded software testing or embedded system testing? Generally, the testing techniques for embedded software includes black box testing, where we are testing the external behavior without knowing the internal code, how the logic is written. And white box testing, it is involves the internal working of the software with respect to the logics and the data flow or the control flow, the code coverage. Here it requires the code knowledge to validate the white box testing. And gray box testing, it is a combination of both the black box and white box testing. Requires some partial knowledge on the code to perform this gray box testing. The types of embedded software testing involve the different stages. The stage one is the unit testing, integration testing, system testing, regression testing, performance testing, stress testing, acceptance testing, alpha testing, beta testing, gamma testing, safety testing, and real-time testing, security testing, compatibility testing. So those are the high-end information to understand how this testing will be covered for the embedded system product. Coming to the unit testing will be a part of the code level testing. It involves some of the tools to write the code and it will be integrated and perform the white box testing. So here, this will be tested under the small functions or the methods and how it can be performed those functions and methods that will be validated. So here we are testing the individual software components or the hardware components with respect to the code level. Here they use some of the tools to perform the testing. Key activity involves testing the individual units, automating this testing with some of the tools, and some of when they are developing the software, it involves the mocking and stubbing. And the benefits of unit testing is it early identifies defects and help to ensure that code is functioning correctly at the individual component level. Coming to the integration testing is the involves the interaction between the different software components or different software or hardware components that ensures that modules functions correctly when integrated into the system. It requires the careful understanding of different components towards the hardware and software that should be validated. The benefit key activities involves the test interaction. After unit testing, various components of the software are integrated and tested. The data flow or the connectivity and hardware software interaction with respect to the protocols that communicating within the devices on the hardware or the software level that can be checked. And the testing interfaces, the point to point or the input and output ports are validated. The benefits of doing integration testing, it detects the issues in the communication between the modules and within the hardware components. Coming to the system testing tests the entire embedded system to ensure that system is the complete functionality or the specification requirements that should be tested on the real world conditions. After the integration, we are performing this system testing activity. We are checking the complete hardware software product in various real-time conditions. Activities involves end-to-end testing and non-functional testing and stress testing will be performed as a part of system testing. So in system testing, we are able to validate on the temperature conditions and some of the load conditions will be validated. And the main part is we are able to validate the boundary conditions of temperatures and the external outputs will be validated how the system will be responded correctly for the respective inputs. The benefits of system testing ensure that system fulfills the functional and non-functional requirements and identify the integration and the sub-level defects. Next will be the part of a regression testing. So regression testing checks the recent code changes or bug fixes features have not negatively impacted the existing functionality to ensure that new modification doesn't introduce the defect into the previously tested functionality. The key activity involves rerunning the previous test cases after any changes in the software. It will be a part of a bug fixing or an adding of new requirements or any updates that we are doing it. So here the regression testing where the selective functionalities will be considered as a part of a regression testing to ensure that small changes it cannot impact on the entire system. The benefits of doing regression testing is it detects the unintended consequence from changes or updates and ensures that existing feature continues to work as expected. Next will be the part of the performance testing. Performance testing is the process of testing how embedded software performs under various loads, conditions, and it includes the response time and the system resource usage like CPU and memory. The key activity involves the response time testing, tough testing, and real-time testing, and memory testing will be performed. The benefits of doing this ensure that system meets its performance requirement, especially critical for time sensitive and resource constant, and validate the systems can be handled at the different loads. Next will be the part of the stress testing. Here, the stress testing pushes the embedded systems behind it normal operation limits to check how it behaves under extreme conditions like heavy load, insufficient resources. To determine the system behavior is stressful conditions like low power, high traffic, or the low memory. So this will be tested as a part of the stress testing. Key activity involves the excessive testing will be performed to check under different conditions and boundary condition testing. And the benefits of doing this is identify the system weakness or failure that can be occurred under different conditions. It helps to improve the roughness and the reliability of the system. Acceptance testing. So acceptance testing is a end user testing where it will ensure that the system is meeting the customer requirement. And it ensures that the embedded system is the product here. It can meet the end user needs and operational requirement. It is done to ensure that product fulfill its requirements and a specifically the user requirement of the product specification is considered as the acceptance of testing. Here, the key activities involve simulating the real world uses and checking the functional requirements and compliance testing will be performed. And the benefits of doing this is ensure that system is ready for deployment and satisfy the customers and regulatory needs and identify the missing features or the functions from the user perspective. This will be tested as a part of acceptance testing and improve the product reliability and reduce the post-production failures. And will be the part of the alpha testing. Alpha testing is the internal testing phase where it will be developed. The complete software will be tested as a internal usage after the user acceptance testing. It will be done on the specific lab environment with the help of the testers. Then the complete product will be released after performing the alpha testing. The key activity involves the internal validation. It will be done by the organization, by the developer or the tester or the product manager, and it will be tested under the lab simulated testing to simulate where ensure that the real world scenario is controlled by setting and identifying the major defects relevant to the hardware or software integration. The benefits of doing this alpha testing involves early bug detection and it saves the cost by fixing the issues before the external testing. Ensure the system is functioning stable before beta release. And examples of this is an automotive issue is tested using in the hardware in simulation before moving to the real vehicle, because the real vehicle it have the brakes and airbags or the high critical hardware equipments that can be tested in the HIL platform to by simulating those features in the simulated way. Next will be the part of the beta testing. It is the real world testing by the external users in terms of usability, performance, and reliability before the final production. Key activity involves user feedback collection. Externally uses the users to test the system in real world conditions and report the usability issues. And performance and testing also performed here in terms of beta testing under the different usages and patterns. And security and compatibility testing also performed here in the part of the beta testing to ensure that smooth operation is happening with respect to the external component and the network, or whether the wired or wireless network. And some conditions it's able to operate how the software is secure. This will be performed as a part of the beta testing from the end user. And benefits of doing this: identify the usability, performance issue from the real world usage, and improve the user experience and customer satisfaction, and reduce the risk of failures after the post deployment. Examples of this: smart IoT devices like Wi-Fi thermostat is provided to selected customer to test the real world temperature variations and network connectivity. And gamma testing is a part of the embedded testing where the user expectations is met with respect to the requirements. And this type of testing is usually performed by the end user or the tester. It will be simulated environment where the future will be tested. And the key activity involved simulating the real world use and checking the functional requirement, and compliance testing, whether the product is followed the compliance towards the safety features that will be tested. And the benefits of doing: ensure that system is ready for deployment and satisfy the customer and regulatory needs, and identify the missing features and functions from the user perspective. This will be a part of the gamma testing where ensure that the compliance is followed efficiently during the coding and deployment. And next will be part of a safety testing. Safety testing ensures that the system is operated in a safe condition and it cannot affect the user. So when it will be operated in different conditions, it is most of the devices are safely, it can be handled with respect to the electronic components that involved in the embedded system. Whenever the failure is triggered, what will be the effect it will create for the user? So that will be operated in different conditions. Here, the key activity: failure mode analysis, redundancy test, and critical path testing will be performed under the safety testing. The benefits of this: to ensure that system behaves safely under all conditions. Here the conditions is whether shut to battery, shut to ground, or open circuit is happened within the device, how it will be created, that will be performed as a part of the safety testing. It is essential for systems in the industries, specifically for the safety standards. And coming to the real world real-time testing, here the real-time testing is the essential for the embedded system where the real-time sensors and actuators will be configured, and that will be tested as a part of the real-time testing. How the sensor is working in the real-time condition and how we are able to operate the outputs, that will be checked. Here, the key activity includes the task scheduling, verifies the system meets its real-time scheduling, and the interrupt handling. If any interrupt is created during the code execution, how the priority will be considered, will be tested as a part of a real-time testing. And latency testing measures if any delay between the event occurring and how the system will be response will be tested as a part of latency testing. The benefits of doing this real-time testing includes ensure the system performs critical tasks in real time and ensure that reliability in the time-sensitive application where delays are not not acceptable. So it's a part of the real-time testing. And security testing. Security testing is essential for every devices that to operate in different areas or different conditions. To if any problem is identified, how it able to authenticate with respect to the user and how it will be solved will be a part of the security testing. Here, the key activity, penetration testing. If any cyber attack is happened on the software module and how it can be protected, the complete software and hardware. And authentication and authorization testing, data integrity testing will be performed in the security testing. And the benefits of doing the security testing identifies and mitigate the security risk in the embedded test system, ensures that integrity of the sensitive data and the safety of the user. And compatible testing. So whenever the hardware and the software is designed specifically for one of the application, the software cannot be swapped to the other devices which are not relevant to the application. So compatibility testing, where the specific software is designed to ensure that the software and the hardware it will be compatible and work for specific applications in the real mode. And the hardware and the operating system are specifically configured and work for some functionality. It includes the key activity, the cross-platform testing, where swapping of the software and the hardware to ensure that compatibility is accepted. If not, it cannot work the hardware and software platform. And hardware compatibility, so like the sensors or displays, actuators will be worked on the compatible devices. If not compatible, it should not be configured and should not be validated. And backward compatibility to ensure that system work with older hardware or the software version, because the software will be keep on upgrading for new features and new functionalities and new threats. The hardware remains same. The hardware always should support the same software whenever there is updations is happening or the older software which are relevant to the main functionalities. The benefits of doing ensure that system works in all supported environment and increases the system marketability by ensuring that it will be compatible for wide range of the devices for new or old. And what are the embedded software testing tools is essential required. Mainly there are some of the tools that used for designing, some tools used for development, tools used for testing of the software. Here, the vendor tools like Vector Canoe, it is for testing the automotive use, canvas simulation and logging and analyzing. And DSpace for HIL testing to simulate the real-time condition and perform the system level testing. Tessie, it for unit level testing. It is automated unit and integrate the testing of embedded system written in C, C++. LDRDA, so for its code analysis and functional safety compliance and automate the tested code. And ETA Synca, it is for use for calibration and measurement of the embedded system. Python scripting is used to automate the test setup and generate the test script. Jenkins for continuous integration, continuous running of the automated scripts. LabVIEW, it is used for test automation, measurement, and mainly for the data acquisition from the hardware. These are the some of the examples of tools that essential for testing the embedded software. What are the other techniques that we involved for performing the testing with respect to the tools? Here, generally, to from the code level, we should keep the breakpoint, and we should that should be tested in the unit testing. And with the emulator or simulator, we'll be the part of the uh, virtual world. The complete software will be tested without need of real hardware connections. And debugger is specifically the code level we are able to operate under different inputs. And the next will be the logical analyzer. It is used to check the electrical signals or the communication between the components to ensure that data transmission and receiving is happening correctly. And the code coverage, this tool measures how much of the code has been tested and help to identify the part of the system that need more attention. What are the challenges in embedded software testing that you usually face? So we need to understand here the challenges includes the hardware dependency. Testing often depends upon the availability of the hardware and the simulator, and timing and real-time constraints. So meeting the real-time constraints make testing more complex, especially when ensure that time-sensitive or tasks are executed correctly. And limited debugging capabilities. Since embedded systems are often a resource constraints, this is a limited debugging support, make it harder to trace the issue. Resource limitation, limited memory and processing power restrictions that use the advanced debugging and logging tool. And interfacing with the external devices. Here, the embedded system often the interact with the real world. Sensors or actuators make it challenging to the simulate to test the interaction between the hardware and software and other components that are integrating here with respect to the digital inputs or the analog inputs that will be tested in the real world unit. And the best practice for embedded software testing here includes the early start early means here the beginning before developing we need to analyze the requirement and we need to check is there any changes that required for the inputs that should be identified earlier, and during the development phase we should identify and detect if that cannot that can be produced or cannot be produced those inputs. It should be validated and use the test automation. Here the automating the repetitive task should save time and ensure that consistent results. And next, test in real environment whenever the possible. Test the system in real world conditions to simulate the actual usage. Focus on critical area. We need to prioritize the safety critical as a higher priority to avoid the high end risk. And boundary testing, it to test under extreme and conditions and lower boundary condition to ensure that stability and reliability is working efficiently. So